From the water that flows from your tap to the electricity that's powering your screen right now, our physical world is run by this hidden digital infrastructure. It's called operational technology, or OT, and figuring out how to secure it is one of the most critical challenges of our time. It really all starts by understanding what happens when that security fails. We're living in an era where a single line of malicious code can cause a physical catastrophe. It's wild. When the digital systems that control our power grids, our factories, our water treatment plants, when they get compromised, the consequences aren't just about losing data. They are real-world disasters. And this isn't just some theoretical idea. In a real attack on a German steel mill, hackers didn't just steal a bunch of files. No, they took control of heavy industrial machinery and caused a furnace to literally melt down. It's a pretty stark reminder that OT security isn't just about protecting information. It's about protecting physical things and keeping people safe. I mean, it sounds like something straight out of science fiction, doesn't it? A computer bug causing a physical meltdown. To really get how this happens, we first need to understand the technology that's beating at the heart of these facilities. So, what exactly is operational technology? Okay, let's pull back the curtain on the systems that make all of modern industry possible. Because to understand the risks, you have to understand the technology itself. And it is a world away from the information technology, the IT, that most of us use every single day. So here's the crucial part. OT directly interacts with the physical world. The best way to think about it is like a digital nervous system for industry. You have sensors that act like nerve endings, gathering information. You have controllers that are like the brain, making decisions. And then you have actuators. These are the components that actually do things, like opening a valve, or spinning a turbine, or moving a giant robotic arm. And what's really amazing is just how complex these systems are. We are not talking about just one computer here. What we're seeing is this intricate web of workstations, logic controllers, sensors measuring things like temperature and pressure, and valves that are constantly opening and closing. It's this incredible dance of hardware and software, all working together perfectly in real time. And this is where the challenge really becomes clear. I mean, look at this. In the IT world of emails and databases, the top priority is keeping secrets, confidentiality. But in the OT world, the number one absolute priority is availability and safety. A power plant can't just go offline for a security patch, right? These systems are expected to run for 15, 20 years, sometimes even longer. And any little change has to be meticulously planned out. You just can't use the same security playbook for both. So because OT systems are so unique, they face a really unique landscape of risks. And it goes way beyond that stereotypical image of a hacker in a hoodie. The National Institute of Standards and Technology, or NIST, actually breaks these threats down into four main categories. You've got your adversarial threats, those are the malicious ones. But then you also have accidental, structural, and even environmental threats. Let's take a look at a quick example of each one. Okay, so here's a classic adversarial attack. In Australia, a disgruntled insider, someone who knew the system, used a simple radio to hijack the controls for a sewage treatment plant. He caused a massive environmental spill. This was a deliberate, malicious act with some very severe real-world consequences. But not all damage is on purpose. In this case, a totally routine IT tool, a simple network scan, was used on a sensitive OT network. The old system couldn't handle it, it just froze up, and poof, $50,000 worth of product was instantly ruined. A complete accident, but a very costly one. And sometimes the technology itself is the source of the problem. At the Browns Ferry nuclear plant, a flood of network data caused both the main and the backup control systems to fail at the exact same time. The design just had this hidden vulnerability, and it forced a manual shutdown of the reactor. And finally, we just can't forget about the physical environment. At Fukushima, the OT systems that were designed to cool the reactors depended on emergency power. When a tsunami knocked out those generators, the control systems lost power, and that led directly to a meltdown. It just goes to show you that OT security has to account for the physical world it lives in. So, okay, that's a lot. Faced with this incredibly complex landscape of risks, how do organizations even begin to protect these critical systems? Well, fortunately, there's a blueprint. NIST outlines a pretty straightforward four-step cycle. And it's not a one-and-done kind of fix, it's a continuous process. First, you frame the risk by really understanding your systems. Then, you assess the specific threats you're facing. After that, you respond by putting controls in place. And critically, you constantly monitor the situation because the landscape is always changing. And this brings us to a really crucial point about this whole strategy. Perfect, absolute 100% security is impossible. It doesn't exist. The real goal is to understand the risks and then manage them down to a level that is acceptable for that organization's specific mission, whether that's keeping the lights on, making a product, or just ensuring public safety. So how does that four-step strategy actually translate into a real-world, secure system? What does a well-defended OT network, a real digital fortress, actually look like? Well, the core concept is something called defense in depth. And honestly, the best way to think of it is like a medieval castle. You don't just have one wall. You have a moat, an outer wall, an inner wall, and then the keep at the very center. Here we see multiple firewalls creating those same kinds of layers, separating the corporate IT network way up at the top from the really critical controllers and physical devices at the very bottom. Let's break that down a bit. The main idea is network segmentation. You create these separate zones for your enterprise systems, your operations management, and your most critical field devices. Firewalls act like the gatekeepers between these zones, only letting necessary and authorized traffic get through. And that little middle ground, the DMZ, or demilitarized zone, that acts as a secure buffer. It's basically a small, isolated network that prevents a direct path from the less secure corporate network to your most sensitive controls. So, as we've seen, operational technology is really the invisible engine of our modern world. And protecting it is this complex, continuous process that has to balance security with the absolute need for safety and availability. And it leaves us with a really critical question to think about. Just how secure are the systems that we all depend on but can't see?